Hi guys, I'm Miss Wendy Zhang. Today I'm gonna go through a special episode with you for 5-star to 5-star problem for plain geometry. That is about some really hard MC problem from the past paper. And first of all, I would like to cover the concept with you first for this ratio in the plane geometry. So it is like a 5-star to 5-star problem. Usually take about 3 to 5 minutes to finish those MC. And I hope after understanding those basic concepts for some triangles for the area, and I hope that you can able to finish it around 2 minutes. So I would say in average, it takes around 1 to 1.5 minutes per question, but this type is take a little bit longer and then need a little bit more progress of understanding as well. Okay, so first of all, for the basic concept, the first figure, the triangle, would be in the similar figure. And then the second type is for finding some area from some same base or same height for the different ratio for the area. And then I would like to go through the first concept with you, and it is about some length and area ratio in the similar figure. So it is a square, and it will be a similar figure because the figure is all square, and I am making them enlarge or reduce their size only. So the length would be the length 1 to 2 for each of the length. Okay, 1 to 2. And then if I say for the area, so it means 1 times 1, it will be 1 cm square. And this one will be 2 times 2, will be 4 cm square. And then the area ratio would be 1 to 2 square, then it means 1 to 4. So you can see their units. The first part will be cm, and the second part will be cm square. That's why if it is similar figure, then I'm making a square on top here. So let me add this square here as well. So 1 square to 2 square, then it means it's like cm square for the unit in the similar figure. Okay, if you can master the skills, similar problem for the triangle. So if I say they are similar triangle and the area would be length square to length square, then it means area 1 to area 2. So that's why we can see the length ratio 1 to 3 originally, then at the end 1 to 3 square, then it means 1 to 9. Okay, so when can we see that they are similar? Then we can see those two types as well. So if I say they have a parallel line, in your S2 we already know that should be AAA, right? And then we can say A and then A, so it's like similar figure, similar triangle. So if I say their length would be 1 to 2, and then their area would be 1 to 2 square, then it means 1 to 4. Then originally I say it's 1 square for this one, and then it means the area of of this area B, C, D, E here should be 4. So what would I present would be? So a triangle AED equals to 4 cm square. Okay, because of 1 square to 2 square. Then this green area would be 4 minus 1, then it means 3 cm square. Okay, next type. So in this one, if I say AB to AD, AB to AD would be 1 to 3. Then in this area would be 1 cm square. And then I'm looking for the underneath part here. So may I know where is a similar triangle? So in this type, since we have a parallel line, then we have these two angles will be the same, and then vertically opposite angle, and this one will be the similar one as well. So I will say triangle ABC is similar to triangle ADE because of AAA. And since we have got 1 to 3, and then this area would be 3 square. Okay, and then it means 3 square, then will be 9 cm square. So this type will basically based on AB to AD, this type, and then it will be 1 square to 3 square. So it means we have 9 cm square. So second type is really common as well. Basically for this two type of similar triangle, once you see some parallel line, and then you automatically think that would be the similar triangle, and then based on different ratio, you find on a different area. Okay, part 2, that for the second part, and then we will find out some area by the same height, same base or same height. So if we say BC to CD would be 1 to 3, and then the area of triangle ABC to triangle ACD, how big would it be? So we need to we need to find out the area, then we need to find out the height and base. If I say BC is a base, may I know where is the height? It should be A, drop it over perpendicularly to BD, right? So if it is right angle, then I would say this one would be the height. Okay? So this one would be the height. Let me say H. If I have to find out the area for ACD, then CD would be the base, and the height would be still H. So may I know what is the area for each of them? Then it should be 1 times height divided by 2, and then to the other ratio, base would be the CD, right? So 3 times height H divided by 2. May I know if I try to simplify them, 2 and 2 will be gone from the denominator, H and H will also be gone. So the area will be 1 to 3. So please mark it down. I would call them, it is a same height problem. If we got the same height, then it means the area will be area equals to base, if it is the same height. Okay, then second part, same case. If we just try to rotate a little bit, and then I will already say the area would be 1 to 3. So this area would be 1, BCD would be 3. Then what about their base, AD and also BD? You can still understand that the height would be C vertically drop it to AB, and then we can still having a right angle, it is the height again. So based on the result from before, base to base will be equal to area. So it means that will be also 1 to 3 for the area. Okay, so next part. Okay, so let's try some example. So BE will be 3, DE will be 1. And please find the area for ABE to the triangle AED for these two areas. So we need to figure out where the height is. So A would be the height, and then since they have a same height again, and then it means we are having the area ratio would be also 3 to 1. This area ratio would be also the same with the base because they got the same height. And then area for ABC, the larger one, to BCD. Okay, let me erase them. So next part, if I say ABC, the larger one, and also this one, this larger one, how big they are. This type is a same base, same height problem. Why? BC is a base. And then the height, we can still see A drop it over right angle, and then D drop it over. They are the same length actually. Sorry that I'm missing information. AD is parallel to BC, so that their length will be the same. And then the height will be also the same. So same base and also same height. Okay, so the base will be the same, and also the height will be the same as well. Okay, so may I know what is the area ratio? That would be the same, exactly the same. It means 1 to 1. Next part, ABE and also DCE. For these two areas, may I know would it be the same? If I say the green one equals to the red one, may I know where is the overlapping one? BCE would be the overlapping one. So what we are thinking is the area would be actually area of triangle ABC minus this blue one, triangle BCE. Yeah, I'm writing down in some short form. And then to the other ratio, area of triangle CDE minus the middle one, BEC as well. So both of them is trying to minus the blue area. And may I know if the green one equals to the red one, so they are already equal to each other, and the blue one also equals to blue one. So may I know, would the area be actually the same? Yes. Then it means also 1:1 ratio. That will be the yellow area. So you can see, whenever you have a trapezium, and then we will find out that these two small yellow triangle, they are exactly the same area, because we are trying to use the larger one minus the blue overlapping area here. Okay, so let's try another question. If BC equals, if BC is 1 and then DE is 3 for the ratio, and then we have triangle ABC equals to 1 cm square, then may I know what about EA to AC? So we see similar triangle. Triangle ABC actually is similar to triangle ADE, and their length would be 1 to 3 as well. So that's why you can see this one would be also 3 and this one would be also 1. So that's why it's 3:1. What about area of ABE for this larger one, and also this one ABC? Their base would be AE to AC. May I know, is it a same height or same base problem? Yes, it is the same height problem. The height is over here with right angle. And then I will say the area will be also 3:1. Okay, same base, same height problem, but different base, so 3:1. Area of triangle ABC to triangle of ADE. So ABC is the green one, and then the other triangle ADE for another this one. So green one to the blue one. Since they are also similar, they're similar figure, and then I will say they are, since it is a similar figure, and then I will say the area ratio would be 1 square to 3 square. That's why the green one would be 1 cm cube, and then it means to the 3 cm cube as well. Then it means 1:9. Then if I say the green one would be 1 cm cube, and what about the blue one? Then it means 9 cm cube, because they are 1:2 ratio. And ABE, the yellow one, I have 1 cm cube already, right? And then this one means 3 cm cube. Then it means 3 cm cube. Then what about the small one? Last one we can also find. That would be also the same area from here to here. As I said before, that would be the same area. Then it means also 3 cm cube square. And then it means we can find out all the area in this trapezium. Okay, so overall we have gone through the similar figure and mixed with the same base, same height problem. And then in the coming video, I will try to figure out each of the difficult MC with you slowly. Okay, so remember type 1, type 2, similar figure, or same base, same height problem. Thank you.